Just. Hello, hello. Yes, it's working. Hello. Good morning.
Good morning, Miss Bates.
Good. Nice. How is it going with you?
Pretty good.
That's good.
I woke up at 7:30 because I don't want to miss this.
Okay. Well, I'm glad you don't want to miss it.
Yes, ma'am.
All right. Still don't have anybody else, as you can see, so because we're a little early. We're about 5 minutes early.
Yes, ma'am.
So in the meantime, were you able to watch the other lectures so that you can catch up or no?
Oh yeah, I can catch up. I watched the other video last night and I
Okay.
had a migraine, so I slept early.
Oh, okay. I'm sorry. I hope you feel much
That's
better
okay.
today.
Oh yes, ma'am.
Good.
Yeah,
Good.
yes, ma'am.
Is your migraine one of those that's sensitive to food or to light or something?
To the heat when I
To
go out
heat.
in the
Ah,
heat
okay.
and when I like exposed to the sun so much, and when I got
Uh-huh.
home, I had a headache and I vomit and I
Oh
puke.
man, I'm so
Yeah,
sorry.
yeah, yes, man.
That is not good.
Mm-hmm. Yeah, but I'm okay right now. I slept really early last night. I think 6 o'clock.
Oh wow.
But
That
I
is
read the
early.
one video when I got home yesterday.
Okay.
Yeah.
Yeah, like I said, the videos are there for you. So if you want to watch them, that's the
Yes,
best way
ma'am.
to do it. And I
Yeah.
forgot to post the other one. I'm gonna do that right now that I'm thinking about it.
Oh, yeah.
Just the link. I have to actually go to Google and I mean not Google to YouTube because
Yes,
that's how I'm
ma'am.
gonna do them from now on instead of taking the bandwidth
Mm-hmm.
from everybody.
Oh,
Yeah, from taking all the space. I mean not the bandwidth, but the space from all of
yeah.
the
Yes,
what do you
ma'am.
call them though?
I was almost I almost quit last month. I mean last 2 months ago. I was almost quit to my school and I had a lot of things because my
Mm-hmm.
husband passed away, just died recently,
Oh, I'm
January,
sorry.
and I feel like, oh my God, like nobody can support us here for moral support, especially moral support, because
Mm-hmm.
he was so supportive to us, and I made it through. Yeah, I'm glad I made it until
Yeah.
summer.
Yes, I'm
Mm.
uploading that video. Let's see, that video was Monday, wasn't it? When I did that?
Yes, ma'am. I'm there.
Okay. Yeah. For some reason I keep thinking yesterday was Monday.
Mhm.
Today is Tuesday, and then I realized it's not. I'm like, oh my God. Where did my
Yeah.
where did my Monday go? And my brain went away. I don't know where it went.
Yeah.
That is so weird. I've
Mhm.
never had that before. It's like all of
Yeah.
a sudden, I think it's because I see you guys. And so
Uh-huh.
I'm thinking it's the first day, even though I've done something already.
Oh.
Does that make sense?
Yeah. That's funny.
Yes, it is.
Yeah.
I was like, I can't believe I did.
Yeah. Is that like the student is just 3 students every Monday? Every Tuesday?
Yeah,
Or there's a lot?
unfortunately, it is. Oh, there's
Ah, okay.
somebody. Isaiah
Ah.
Matthews. Okay, I don't know who that is. Maybe I have a new one. 7,
Mhm.
what was yesterday? 12, 2022. And that is SCHE 110. Yes, I'm just gonna call it
Good
one.
morning, Mrs. Body.
Good morning. Who is this?
Madalisha Clayville.
Oh, hello. Okay. I was not sure who this was because of the name that came up on my,
Yeah.
What does it say? How can I change it? Let me see.
It says some person, Isaac something.
Wow. Give me.
Yeah, hold on. Okay. Hope Jacqueline can make it.
Yeah. Hi, Jacqueline.
Hey.
There she is.
Yeah. I had fun last night, yesterday to our lecture. Really fun.
You know, one of the things we did not cover yesterday also, and I just realized, we did not cover how to do multiplication in scientific notation. Okay. Next. Okay. So I am making these, you know, the YouTube video for you guys of yesterday. No, not yesterday, Monday. See, I'm still there. I don't know what happened to me, but I lost a day. Oh no, public. Okay. All right. Publish. Okay. All right. So here we go. I am going back and we're gonna start sharing. Spring. I've got the okay. Mhm. Okay. The Zoom. There we go. Sorry, I'm just trying to find everything right now. So Jacqueline Johnson. And there we go. Alicia, I see your name now. All right. So there we go. That's where we are now. We are going to head to the next section. And remember, don't forget that you have to be doing the topic forums as we go, right? So right now, this is the one that is, you know, in the topic 3, because why is it important to convert from one unit to another? Well, that's where you would answer that one and provide an example in which you would use conversion. It doesn't have to be an example of your everyday, you know, of this. It could be something from everyday life, like I was showing you that you could, you know, go to Canada and figure out if you had enough money or not to buy something, that kind of thing. Okay. Something like that, or be cooking, or even a nursing problem would be something, you know, like somebody says, administer 10 micrograms per kilogram body weight. And you're like, well, what's kilograms? You know, that's there you go. You have a conversion right there. And there's a lot of other conversions to be made here, but that's one of the ones. Okay, so see, that's the one where I got the introduction to dimension analysis. I didn't introduce the mnemonic device either.
I don't mean to cut you off, Mrs. Valdez. Are we gonna do these lectures today? The ones that you're pointing right now?
No, the ones that I'm pointing to right now, we've already done. That's what I was saying. So
Or can I,
you weren't there
or can I,
yesterday. So you can watch
or
these.
can I use those to do the form?
Yeah, you can watch these right here, right?
Okay.
And like I told everybody else, if there is nobody, you know, if somebody doesn't answer on the forum, you can always just answer yourself, you know, because not everybody tends to be here and do the forums, even though I mentioned them many times, but they help you learn, believe it or not, and do it substantively, you know, don't just say, I like your answer. Yes, that's lovely, but what did you just say? I can say I like your answer and not read it, right? I mean, I like your answer. You know, another way that conversions are used is in engineering or is in whatever, you know, and here's an example, that kind of thing. You know, that would make it substantive. And then you put your source. Okay, so we covered all the way to temperature conversions, covered density yesterday, and we covered operations with scientific notation, but there is one thing I forgot. I did not cover, and I'm gonna go there right now with how to do, let's see, there we go. So we're gonna go here. This one has a problem on addition and subtraction. So we're gonna go to this one first because you are gonna encounter addition and subtraction also with scientific notation. And if I don't cover it, I'll be missing, you'll be missing something. So let me go to it. Okay, that's accuracy and precision. We don't want to do that one yet. The SCHE, nope. Okay, there we go, scientific notation. Okay, there we go. This is the one, addition and subtraction. All right, so for addition and subtraction, it's pretty easy as far as it goes, right? What you have to remember is that if you have the same exponent, you can add them or subtract them, just like if the exponent wasn't there. But if you don't have the same exponent, you have to convert one to the other. Okay, so let's review real quick what this is. So scientific notation, remember, expresses a number in this form, right? The M and the N, remember those two, because we're going to be referring to as the M and the N. All right, so that number has between 1 and 10. So it can be equal to 1, but it cannot be equal to 10. In other words, it can be 9.99920 times, you know, but it cannot be 10 because 10 is 2 digits and it can only have 1 digit to the right of the. And that can be any integer, positive or negative, right? That's what that means. All right, so right here, when we're adding these, like I said, we just add the M's, right? Very simple, since they are the same exponent. Add the M's and then just bring down the N. You see that? Very simple. I mean, this is like addition in the in you know,
Okay, so
elementary school, basically.
so this is just adding the exponents. We just drop down the first.
Yeah, this is, yes, this is just as if you were doing math, you know, normal math. So you
But
just
what if?
bring down,
But
but
what if
only if
the
they're the same.
exponents?
Yeah,
Oh,
well,
okay, yeah, that's what
I'm
I was
about
gonna
to
ask.
show you. I'm about to show you. Okay, subtraction, same thing, right? So that would be 1, right? Times 10 to the 6. Okay, that's easy too. Very easy. But if they're like this, no, it's not as easy. Because you cannot add apples and oranges. And this is apples and this is oranges, right? So they're different. So you cannot say 4 plus 3 is 7 and then bring down. What do you bring down? See, there's the problem. You don't know what to bring down. You can't. So what you need to do is you need to convert. Here's student number one, what he'll do, okay? Or student name. He or she, I don't care, either one. They'll change this one. Remember what we do to the M, right? We do the opposite to the M. Did you see what they did? Okay, so it was 4, right? So we're increasing to 40. Therefore, we need to decrease the exponent to 5. And that's, now it matches, right? And now when it matches, you get 43 times 10 to the 5th. But that is incorrect scientific notation because we just talked about that first number has to be between 1 and 10, and that is not, right? So now we need to still do another step, which is to back it up, right? We back it up. 1, that means we're decreasing by 1, so we must increase the exponent by 1. And there's your answer. Okay? So that was a lot of steps, wasn't it? So in order to avoid that, always, listen to this, always move the decimal on the smaller number, not the larger, okay? So let's look at student B. Okay, so which one's the smaller number? Obviously, the 3, right?
The 3.
And I'm talking about 3 times 10 to the 5th, right? So this is the number, the whole number, not just the 3, but the 10 to the 5th too, okay? So what we're gonna do is we're gonna decrease the 3 so that we can increase the 5. So it becomes 4.3 times 10 to the 6th. Isn't that the same answer we just had? Except this time we took a lot less steps to do it, right? Because we moved the smaller one rather than the larger one, okay?
Okay.
So that's how you would do them. Let's do one on yours. Try that one. And this is with a negative. So if it helps you to do a number line, do a number line. That's one of the things that a lot of people get confused with, the positives and negatives. So if you do a number line, let me do a number line for you actually, because I think it'll help you. Remember the number lines, the 0, right? And then you got 1, 2, 3, 4. Going this way, that's the positive side. But over here, you got 1, 2, 3, 4. All negative, right? Going that way. So the closer something is to 0, the larger it'll be, right? So that means which one of these is the smallest of these two numbers? Which one are you going to change and how are you going to change it? You have to think about that.
The 2.37.
Yes, the 2.37 is the smallest because that is
Yeah.
all the way over here. See, 5 would be here and 6 would be just over here. So we're moving from here to here, right? You see, you have to move that exponent, right? From -6 to -4. So what do we need to do to the M to get the N to -4?
We're gonna move the decimal twice.
Yes, but are we increasing it or decreasing it?
Decreasing it.
Decrease.
Decrease, very good, excellent. So now you do the math and tell me what you get.
Okay.
Since you've got the steps just right, everything looks good. Oh, and yeah, it's an addition.
Let me see.
So 2 point.
Hello. Good morning. So are we adding the exponents?
No, you don't add the exponents. Bring them down, remember, but you have to change it
Okay,
so that you can add the m's.
okay.
Yo, I had said in my mom house last night, she was like, go take your lunch. And I was like, yo.
So I get 8.3 times 10
We did say.
plus 2.
No, we did. We was gonna take the test, but then Alex was hungry. I don't got no food.
I'm sorry, what?
I mean, I add the 2.37 plus 3.48, right?
No, no,
I do
because you
not.
have to change the 10 to the -6 to 10 to the -4.
Uh-huh.
So you have to move your decimal accordingly.
Okay,
Oh,
So it's not gonna be 2.37 anymore. It's gonna be something else.
okay.
Okay, I think I have an answer, but I might be wrong.
Okay?
23.7.
I got 350.37 times 10 to the negative
Minus
6
6.
power.
Yeah, yeah, that's actually that is correct, except it's not 300, it's 3.5, right? Because you got to keep that decimal.
Okay, yeah.
3.5,
Okay.
okay. So would that be 2.4?
23 point.
Yeah. So, okay. So you got it right, and everybody else needs to follow your lead so they can get it right too. So basically, what I told you is how would you get -6 to -4, right? Up here, right? Because this is the smallest.
Okay.
So she said you could move this decimal. And she said decreasing it by 2, right? So decreasing it 2 spots. So if you decrease it 2 spots, right?
Yeah.
That would be there, right?
Oh, okay.
So when you add that, you have to reposition it, obviously, because you cannot add it as is. It's weird. And then this becomes, since we decreased that by 2, you increase this one by 2, right? And it becomes -4, you see, when you do that. Then you can add it. That's the only time you can add it, if they're the same. Okay, so let's see what we would do. All right, let me clear all this stuff so that you can see it in action. Okay, so that's the one we target, right? We move it back 2 spots. Okay. And then becomes this, you see? Like I said, reposition it so that your decimals are in the right spot, right? So when you add, it's gonna be that. See that?
I didn't get anything close to that.
That's
Okay.
because you didn't follow the steps as, you know, as I said them when I said them. And that's okay. I was just saying them, so that's why. All right, let's do another one. Let's do, okay, I'm just gonna write it on here on the screen. I'm gonna make it up as I'm going, so let's just do one. All right, so let's do 2.5.
Let me see. Gonna wait.
To the fifth. And we're gonna do a subtraction this time. So minus 3.7. Okay, so how would you do this one? Remember, you always move the smallest one.
This is a new problem we're working on.
Yes, I'm just putting
Okay.
it on there for you, just, you know,
Oh.
so that you can
Okay.
work on it. And it's, you know, this is subtraction.
Oh, just as this was gonna be the place. Somebody down there. Oh, not gonna go home. We not going home.
Zero.
Don't give up. I believe. They're gonna do it to you.
Mm.
Come on, man. I'm do something. See you there.
So would the exponents be 12?
No,
No,
No.
okay.
It's
No,
gonna
remember.
it's gonna be 7, right?
right. Yes, because you gotta move the smallest of the numbers, right? So that it becomes 7. So in order for it to become 7, don't you have to add 2, right? Which
Oh,
means you
I'm-
have to decrease this by 2, right?
I think I have the answer.
Okay,
It's gonna be negative 3.8444 times 10 to the 7th power.
correct.
You
3/4,
go,
right?
girl.
That is correct.
Thank
Yes.
y'all.
Yes, that is the actual answer. So remember, you have to have the same exponent. You can't just add them. They're apples and oranges. You still have apples and oranges if you put them together, right? So you can't do that. You have to convert one to the other. And the suggestion is that you always convert the lowest number. And the lowest number in these was the 10 to the 5th, right? Because that's much smaller than 10 to the 7th. Actually 100 times smaller. So, okay. You want to do another one?
Yes, please.
Okay, let's clear that. Let me give you a twist. One that you have a positive and a negative. See how you do that one. All right, let me see. We're gonna do an addition again. Well, let's do 10 to the, yeah. That's good. Plus, we're gonna do 4 times 6, 8 times 10 to the -1. That one's easier to know which one's the lower one, right?
Call your papa, see what he want. Call your papa, see what he want.
And the number line would help you figure out how many times to move it. If you need a number line, you could do one.
Bây giờ mình sẽ có những như là hàng rồi có một like cái nào we có thể keep it for you know the giá là
Is it 8.25 times 10 to the third?
No,
No.
no. Remember, you have to change the low one, right, to meet the high, so that the exponents are the same. You can't add them like this.
Okay.
So what do? Okay?
Is it
So in order to get to 2, don't you have to add 3? Right?
Okay, so I got
You have
3.
to add 3, you have to decrease it by 3, right?
Okay.
Plus 3, 1, 2, 3.
is it 3.57468 times 10 to the second power?
Yes. That is correct.
So how did she get the second power?
Right here, look.
You add 3.
See, if you add 3 to it, right? Because that's what you want. You want to get to the second power. So what is -1 plus 3 is 2, right?
Oh, the negative. Okay.
Yeah, remember, it's a -1 right here. This is a negative. So if you have a -1, you are actually going to move across a number line. You're going to move like this. Look. So this is your -1, this is your 0, this is your 1, this is your 2. I know it's kind of hard to read. And this is your 3. Okay, so you're going to move from here. So you're going to move 1, 2, 3 spots. You see that? So I said sometimes a number line helps you figure out that, or you can just do math like I showed you. Either one. So you know you're going to move 3 spots by increasing it. So then that means you're going to have to decrease this one 3 spots. So now when you add, let me erase all of this and show you what it would be. Okay, so when you add it, remember you have to reposition it because otherwise it doesn't work. All right, so when you add it, so it's going to be 0.00. It was 468, right?
Right here,
Times 10 to the second. And let's reposition this too so that it's not in our way. Okay, so when you add it now, it would just be very easy. It would be 3.574668. You see that? Times 10 to the second. Now you can just bring down the exponent. Let me get this number line out of the way. Because this is getting in your way here. There. Okay. See?
Okay. 157. 0, 0.
The funny thing with this is when you are looking at sig figs too, you didn't really make a change, right? Because if you're cutting it off at the lowest amount of decimals, right? Which in case the last time it was, sorry, the last time it was 2, right? It was always 2. So you would cut it there. And then you would have actually the same number, which is funny with sig figs. But that's, I just wanted you to be aware that sometimes it doesn't make much of a difference. If your distance is great, it might not make much of a difference depending on the number. All right, so we're going to clear that. And you guys got the steps. So basically what you need to do is identify, you might want to write this down. Step 1, identify the smallest of the 2 numbers, right? So let me see, let me clear all of this and let me let you watch it again so we can do the steps as we do it. Okay, so let me go back. Okay, so here's our first step. We need to identify the smallest of the 2 numbers, right? So oops, to do that, we have identified it, right? That's what the green. Then adjust the exponent and the number so that they are the same as the number that you want to go to, which is -4. So in this case, you know that you need to add 2, right? So if you need to add 2 to this one, right? That means you need to decrease this one by 2, right? 0.0, missing 1, no, sorry, yeah, sorry, this is too many. I went too far with that one. Right, so like that, right? You move it by 2. Okay, then reposition your numbers, right? So remember, now this is a -4. This number right here is now a -4, so that's your steps. Reposition your numbers, so that's the next step. Once you've changed it, which we're about to do, that's our next step. And you notice that it's going to meet what I just did. Okay. See, reposition your numbers, which we haven't done yet. Now we're going to reposition with the new quantities that we just made, right? And then add or subtract, whatever the operation indicates. So in this case, it's an addition. So just add the numbers together. That's it. That's how you solve one of these. So there's 3 steps. First, identify the lowest number or the smallest number. Second, adjust the exponent and the number, the m and the n, right, according, so that they meet the larger number. And step 3, add or subtract, whichever, you know, your operation indicates. All right, so that's all of it. All right, so we're going to stop here and we're going to go to error, which is over here. I know this, I'm doing this backwards and forwards, but there's a reason. I believe that it's best to know certain things before others. Okay, so here, this is measurement. This is when you measure something, right? You are going to use some sort of instrument. And any measurement that you make is going to have 2 parts. Number 1 is the part is the number, right? And the second one is your unit or your scale. So you've got to have both in order for me to say, so what about if I say, I'm going to measure this and I say it measured 5, then you're like, 5 what? It's like an untold story, like you know, like unfinished story. I said it measured 5. but you don't know 5 what if I don't say what the unit is, right? If I say 5 feet, oh, then you have an idea. If I say 5 meters, you have another idea. If I say 5 kilometers, then wow, that's a long way, right? So you see, it does make a difference if you do a scale. So every measurement needs a scale. Examples, 20 grams. See, you know that's a little number. Joules per second. Maybe you do not know what that means, but you have a unit. You know, so these are some of the units that are the fundamental units. And pay attention to the only one that is not what you would think it would be. And that would be mass. Mass is the kilogram. Everything else has no prefixes. You notice that? So in other words, it's not the gram for mass, it's the kilogram, okay? So if I ask you, what is the fundamental unit of temperature in the metric system, you would say Kelvin, right? What is the fundamental unit of time? Then you would say second. Length, you would say meter. In mass, you wouldn't say gram, you would say kilogram. And then these other ones are just here for you to know. Ampere, mole. Mole is actually the amount of substance, and this is a unique to chemistry. Of course, we use it in other things too, but it is a unit for chemistry because it's the amount of molecules or particles in a mole. And then you got luminous intensity, like how bright something is, that's measured in candelas. All right, so that's your fundamental units. All right, so let's keep going. And there are all these connections. I know there's a lot, but I just wanted you to see that all of these little units right here make a ton of other units. These are known as base units, and these are known as derived units. Why are they derived? You notice volume is missing out of here, right? Out of the base units, you notice there's no volume, like liter. The reason that it's not there is because it is a derived unit, okay? See, liter is somewhere in here. I don't see it in here, no. But it is one of those derived units. So, oh, there it is. Yeah, there it is. So these do not have special names, but they are the units of volume. So in this case, meter cube is a liter. Centimeter cube is a milliliter. All right, so here we've already looked at these. The prefixes common to chemistry are these that you'll see the most, but there's, you will also see, nowadays, you have a lot more than these that you use. I mean, if you hear, oh, my computer has 10 giga, you know, or 100 gigabytes or whatever, you know, it's like, okay, what is giga? It's not on there. So that's why I gave you that one, that, you know, that sheet that you needed to get that looks like a table with lots of lines on it. And the one I gave you in the classroom, but then I showed you where to get it. I'll show you again, but you need that one because all of those. Okay, so when you are looking at measurements, okay, you know, they are always done with any kind of instrument, right? Depending on what you're measuring. So if you're performing a measurement with an instrument, you are limited to the number of decimal places that you can get because no instrument can measure all of them, right? There's an infinite number. So in this case, look at these balances. See, they're all measuring mass, right? So if you look at them, you're like, okay, that one right there only has like one little thing and plus an extra one maybe, and that's it, right? This one has quite a few because you got the number and you've got all these other numbers. So you got at least 3 or 4 the significant figures in that one. But this one right here measures all the way to 4. Okay. So they're very, very precise. Okay, what is precision and what is accuracy? Okay, so if I say something is accurate, that means that it is very close to what it should be. So it is in agreement with its true value meaning the value that you find in a book or the value that your target value, right? All right, if I say that number is precise, that just means you have made several measurements and the numbers agree with each other. They can be as far away from being accurate as possible, but if they're precise, that means they're really close to each other. It makes no difference how accurate they are. So right here, based on what I just said, look at this bullseye right here. What would you say that is? Accurate, precise, or neither? What's the object of throwing an arrow? I mean, of launching an arrow is to hit the bullseye, right? The red part. So is this person accurate or precise?
Precise?
Or neither? Because it could be neither.
Neither.
Neither. Okay, you say
Neither.
neither? Okay. The answer is neither. Yes, you're right. Because it didn't hit, he didn't hit anything. And look, they're all over the place, right? All right, let's look at this one. Is this person accurate, precise, or neither?
Neither.
Neither.
Actually, look at what precision says.
Oh, several measure. Oh, made in the same month. Okay,
they're-
that's precise.
they are
Oh, yeah.
So it's in
Yeah,
the, in
so
the
it is
same
precise, right? See how they're
Yeah.
close together, but they're not anywhere near the bullseye. That'd be, yeah.
Okay.
But not accurate. What about this guy?
Accurate.
accurate.
That one is accurate and precise, right? Because they're
Mhm.
both, not only is he in the bullseye, but they're also close together. So see, that's what we want to look at. We want to look at measurements that you don't want whenever you measure something 3 times to be all spread out like this, because then you don't have precision. That means your instrument, you don't know what you're doing, or your instrument is totally wrong or something, you know? If you have a measurement that's off, but they're all the same, that indicates that either you have poor technique or your instrument needs to be recalibrated, right?
Mhm.
One of the two. And if you're here, that means everything's good, you see? So that's why we have measurements, and that's why we have accuracy and precision, right? So we have 2 types of error that we can incur, and one of them is called random error. That means this measurement has an equal possibility of going up or going down, you know, being higher than you should have been or lower than you should have been. So it's just random. We don't know what causes it. And then there's systematic error. This is where you actually know that every time that you're measuring, you're too low or you're too high. Well, that points out to one of 2 things, either poor technique or incorrect calibration of your instrument. Because if it is the same direction each time, then something's happening here. And that's why I said you would probably need to, oh, and that's it. We already did the sig figs. So, okay. So that is what accuracy and precision are. Now let's go back to where our accuracy and precision PowerPoint is. Remember I told you we'd do that and then we'd go on. Okay. So accuracy and precision right here. It's coming. It just takes a little time for it to download. Okay. So we have, what is the difference between one and the other? Well, let's look at it. If this graph increases, the precision increases as it goes up and the accuracy increases as it goes to the right, obviously the most precise and accurate would be this one, right? This one's still accurate, but it's not precise because even though it's accurate, they're not all bunched up. You see that? This one is very precise and this one is not precise nor accurate. So you can kind of see that. All right, so let's do, what is the difference? Well, if you actually look up for a word to give you an idea of what accuracy is, it would be on target or exact, right? That would be your words. So you notice it says it only requires one value and the true value. That's all you need, because you can actually do this math, which is known as percent error right here with this formula. So you might want to write this formula down so you'll have it. So percent error is equal to the experimental value. That's the value that you measured, minus the actual value. That's the value that is either given to you or you found it in literature, you know, depending on what it is. Divided by the actual value again, times 100, okay? So write this down, and that's your percent error. That is the measure of how accurate you are. Your measurement is, I should say, okay?
Measurement of what?
Yeah.
Can you repeat that, please?
The measurement of how accurate your that is the way to determine how accurate your measurement is.
Okay.
Okay, so you take your experimental value, so the value that you measure minus the actual value, divided by the actual value, and then multiply times 100. So that's accuracy. Now look at precision. Precision is actually reproducibility. So that means you can do it over and over and over. If you can do it over and over and over and it's still off, that means something's wrong, right? But we don't care in this case. We are trying to measure how accurate, how precise, sorry, your measurements are. So if you are doing this, it requires several measurements. You cannot do it with just one. It has nothing to do with the true value. You see that? So it's totally the opposite of the first one. But to calculate it, you use this formula. So percent difference is equal to the highest value minus the lowest value over the average value. So basically you add up all your numbers, divide them by the number of them, and that's your average times 100. So it's more involved to see how accurate you are, how precise you are, I mean, excuse me. Okay, so now let's look at some. Okay, does that represent accuracy or precision?
Precision.
Okay, you're correct. Okay, what about this one? Accurate or precise or both?
Accurate.
Accurate.
Accurate. Accurate.
Accurate only?
I said
Both.
both.
You say both? Okay, let's see who's right.
Yeah.
You're right. All right, what about, so see, in order to be accurate and precise, you must look at you hitting the target and they're close together, right? All right, what about these numbers? See, now you're looking at data. Okay, if the sample is known to weigh 3.182 grams and she weighed it 5 different times, and this is your resulting data, which measurement is the most accurate?
3.200.
3.200, you sure? Because look at what the actual
Which
measurement is,
measurement is the
3.182. So which one's the closest to 3.182? That's basically what we're asking.
3.180.
3.180, right? Correct. See? You can tell, right? Because you have the actual measurement. All right. What about, it's only 0.02 away, right? 0.002 away, actually. All right, let's look at this one. Now, in this case, we want to know which one is the most precise. Student A, student B, or student C? Look at their numbers and tell me.
The 14.4.
Well, you
no.
said A, B,
Yeah.
or C. No, it's the whole measurement.
The whole measurement. Okay.
Who's the most precise?
The 4.5. The C.
Student C
14.4.
is the most precise, you say?
Yes, ma'am.
Anybody else want to say something different, or you're all in agreement?
I'm not sure.
Okay, remember, precision
That's the
means,
closest.
precision means how close they are to each other.
Mhm.
Accuracy means how close they are to the target. And the target value is 14.5.
Okay.
So in this case, I'm asking which one is most precise, not accurate, precise.
Precise.
Mhm.
The student C.
You
I
say
say
student C.
student A.
You say student A, okay?
Mhm.
Let's see who's right. Aha, student A. Why did you say student A?
Because of the 14.8s and the 7.
There's only 0.1 difference between all the numbers, right?
Mhm.
Whereas student C, there's one that is 14.6, which
Right.
means it's 0.2 difference. So
Okay.
yes, you're correct.
Okay.
Now, if now I change the question to which one's the most accurate, which one's the right answer this time?
C.
This time it's C, right? Because it is the
Yeah.
closest to 14.5.
Yeah.
Yes,
See.
that would be correct. Yes. So you see the difference now, right?
Mhm.
Okay, so let's keep going. Let's do a few more. All right. Oh, sorry. There. Answer student A had the most precise work since there's only 0.1 centimeter between the highest and lowest value. And student C had the most accurate since the measurements were exactly at the true value and the other three were only 0.1 centimeter away from the actual. So there you go. That's how you do it. Now, if this was an archery tournament, one of these would be, you know, in order to win this tournament, you have to be both accurate and precise. So this guy right here, he split the arrow. Look, couldn't be more accurate and more precise, right? This guy, that's more like me right there. I don't know. I'd be more like all over the place rather than just precise. This is actually good precision though, right? Because it's pretty close together. So that means that they need to adjust their vision over to the right a little bit and up. This guy, he did pretty good, but he missed a couple of times. So he's pretty accurate and pretty precise again. And this one, excellent, right? So obviously that was Robin Hood right there. Because or whoever, or arrow or whatever that splits the arrow, you know, the green arrow, you know, the famed superhero or somebody. Okay, so now when we're doing metric conversions and we did these, remember how we did these? We're gonna do a quick review. Okay, so remember what we're looking at. We're looking at converting meters to kilometers. So we're gonna have to go up or down.
Up.
No, yeah, we're going
Down?
up from meters,
Going up.
yes. How many
Okay.
spots?
I think it was 3.
You are correct.
Okay.
So since we're going up, that means we're decreasing, right? We're moving negative. So if we take 345 and decrease it 3 times, that'd be 1, 2, 3. The answer would be 3, wouldn't it?
Okay,
See?
okay.
Mhm.
Okay. All right. What about centigrams to grams? Okay, we're moving up again, right? And
Okay,
in this case, if you have your sheets, it would be more helpful.
yeah,
Yeah, you can download them and be looking at them. Let me see.
Okay.
Let me show you where they are for the people that are just now new to this thing. Oh yeah, right here. See where it says metric conversion chart and then
Mhm.
metric to, okay, so that's the one you want right now because we're doing nothing but metrics. And it looks like that. And we're going from centi, right, to grams. Oh, so let me make it a little bit bigger so you can see it better. Okay, we're going from centi to grams. Centi to the unit. Remember, unit is grams because this is the one without the prefix. So centi, we're going 1, 2. We're going up, so that's a negative direction, right? So that means we're decreasing. All right, so, all right, right here. Oops, I gotta go back to my, I know I have to do a lot of stuff to get there, but all right. So, all right, so we're looking at that one. And we have to move it in a negative direction 2 times. So that means the answer is 1, 2, 3, or 4.
4,7,500.
Negative direction.
Oh,
0.
007.
This is 2.
So it's 2, correct?
2. Okay.
Yes. See? All right. Kilometers to centimeters. Okay, let's go back. I'm gonna have to do this a couple of times here. All right, so once again, the conversion chart. So you guys need to download yours
Okay.
and have it so that you can be looking at it. Okay,
Mhm.
kilometers. So we're going from kilo to centi, right? And we're moving in a downward directions, which means it's positive.
Mhm.
Okay, so we're going 1, 2, 3, 4, 5. You see that?
Okay.
It's
Yes.
5 plus. So, okay, so let's go back. And I know the answer is already on there, but since we know we need to move 5, increasing, right? That means 1,
Yeah.
2, 3, 4, 5. So it means we got 3 zeros after that one. So it must be 4, right?
Mm.
And that's correct. All right. So there you go. So the limits of measurement, remember this is what the 2 words mean, okay? One last time, just to look at it one last time. Accuracy means how close you are to the true value, or if you want to call it exact or on target or whatever, that's good, right? And that's what it means, that you can only be as accurate as your instrument. In other words, you cannot go past what the instrument can measure, right? Because you can't. There's a limit. All right. Or look at that one. If I'm asking you to measure that, what would you say this measures?
Precise.
Well, you know for a fact that it's 8, right?
Mhm.
And you can see that it's less than a half, right?
Yes.
So where would you put it? 8 points what?
5.
No.
No.
8.3.
8.3, okay. Yeah, we definitely agree that it's at least 8, right? We definitely,
Mhm.
no. All right. So look at that, 8.3. Very good. Excellent. All right. Now let's remove the things that are covering our little. Okay. So this is how we would actually write it. 8.3 plus or minus 0.1, right? Because it could have been 0.4 and it could have been 0.2, right? Because we can't really measure that. Now let's actually do. So that what that means is that I am confident that you can measure that within 0.1 centimeter of 8.3, which I think you could do that. All right. Well, look at that. Now we can actually see it.
Yep, two.
Not quite two though. You know, this is a little past two.
Yeah,
So
pass up
now we
to
can say 8.2 what?
1.1 or 0.2. Oh,
8.21 or 8.22.
Okay.
Yeah, exactly. Exactly. See how?
looks like one.
Okay. So there you go. Plus or minus 0.01. Because you say 8.1 and I had said 8.2. So you see, 8.22, I mean. So see, it's plus or minus 0.01 this time. So it became a little bit more
You have one more
precise, right? More accurate.
Mhm.
We can actually measure more because we have more spots. If we had 10 more little divisions there, we could measure even one more, right? Okay, all measurement. And yes, you can measure that. You can rewrite it and say it like this, right? But either way, it doesn't matter. Okay, so the limits of measurement is what you're looking at. Precision of a calculated answer is limited by the least precise measurement used. That's why the significant figures are used that way, you see? Because the least precise, that's the one that you're going to give all the precision to everything else. So basically, if you had a box and it measured something like 3.4 centimeters by 5.62 centimeters by 7.7, not just say 7 centimeters. When you multiply this, and these are points, by the way. All right, so when you multiplied all that, your answer would be limited to 1 sig fig because that one right there limits everybody else. You see that? See how that works?
Mm.
I'm confused.
Okay, so basically, remember we did sig figs before?
Mhm.
And the rule says that you cannot have more when you're multiplying or dividing, you cannot have more significant figures than the lowest amount. And the lowest
Okay.
amount would be 7, right? Which is, I mean, this one, the one that only has 1 sig fig, right? So
Oh,
then
okay.
if you multiplied all of this, so we had 3.4 times 5.62 times 7, that gives me 133.756 centimeter cube. Okay, that's what I got. But we have to limit our answer to 1 sig fig. So that means we have to cut it right there because we can
Okay.
only be short of 1.
Yeah.
So that means this is 100, right?
Mm-hmm.
Because this 3 is not large enough to make that go to 2, right? So
Okay.
it's 1, 0, 0, because we always have to keep our decimal, right? So we have to put place zeros, placement zeros, they call it. All right. So the answer with sig figs would be 100 square centimeters. I mean, cubic centimeters, excuse me. So only because of that 7. Now, let's clear this bottom right here, okay? And change this measurement and say this measurement now says 7.0 centimeters because somebody decided that they could actually measure that last number and it was exact. So they have to add the 0.0. Now we have the same number, 133.756 cubic centimeters when we multiply, but we can actually keep 2 sig figs. So that means we have to cut it here. So in this case, this number became 130. You see that?
Mm-hmm.
Okay. So let's say now somebody said, you know what, when I measured, I actually could measure more than that, right? I know, here we go again. And now I have a 0 here and a 0 here. Now you can actually get 3 sig figs. So your measurement that was 133.756, you can actually keep up to here. And this 7 is large enough to make that go to 134, right? See how each time we got a totally different answer?
Mm-hmm.
And that's
Yeah.
because each time we added one significant figure. Because since we added one more to these measurements, right? We were able to actually keep that many more. That's what all this is. All precision is that when you're talking about measurement. It is always shown. You cannot say, you know, when you measure something, you cannot say, I measured it to this many significant figures. You actually write that number with the amount of significant figures. And that makes everybody know how accurate, how precise your measurement is. All right. So that is it for precision and accuracy. Oh, let me just clear all those rooms. Okay. So let me finish with this one. Okay. So a ruler with millimeters should give you a more precise measurement than a ruler with just centimeters, just exactly like what we did with the pencil. So when you're reading an instrument, remember you may only estimate one place beyond the smallest unit you actually measure, which is what we did when we did that little exercise with the pencil, right? We could go one beyond because we could see more. Okay. And that is known as what the one that you estimate is known as the uncertain digit. And most measurements have an uncertain digit unless they're exactly on the line, right? And then you measured it, so you got to put a 0.0. All right. So this is how we keep track. Okay. All right. So that's that. Now, let's go and do our review of all the stuff we've learned so far. I need to enable editing because we're going to have both of these sheets open. All right. So this is the skills review that I asked you guys to print. All right. Let me go ahead. You notice we're starting with what we just learned, percent error, right? So for percent error, remember it was the actual, no, the measured, right? The one you measure. So if the experimenter measured 24.5, that would be what we want. So it would be 24.5 Celsius minus 31.2 Celsius divided by 31.2 Celsius times 100, right? Okay, so when we do that math, we're applying that formula that we learned. And yes, it is going to be a negative, and all the negative is going to tell us is if it's higher or lower than the actual, right? And in this case, it's lower. So her percent error is very big. It's 21. So the answer is negative, right? And you can put negative, it's fine. 21 point. And if we were to go by sig figs, we would find that we have 2 sig figs to go. So that's it, 21%, right? So she's way off. And you can see that just by looking at it, right? That she's way off. All right, we're doing the same thing with molar mass of butane. So just go ahead and do this math just like I did here and see what you get. You notice it says Tyrone actually calculated to be 44.2. And it's actually 58.14. What did you guys get?
Is it 3.367?
No, it's negative 23.98 something. Remember to hit equal before you divide.
Okay. So let's see if I'm doing this right.
Otherwise, it's dividing something else.
Like 1.315.
Okay, so when you subtract it, you got 3 sig figs. So you can actually have 3 sig figs in here. So according to what I get 23.98 something or something like that. Hold on, let me do it again. Let's see, 44.2 minus 58.14, right? That gives me negative 13.94 divided by 58.14 again. Remember that it has to be divided again. And then multiply times 100. And that gives me negative 23.97660.819. Okay, since it is 23.98, that means this is going to be 24 and it's negative 0.0%, right?
Okay.
Because we could actually measure all of that. Because when we subtracted on the first one, our numbers that we got were only 2 sig figs, right? So that's why we only could keep 2. But there you go. So that is your answers. And they're both lower. See that negative just telling me that is lower than the actual. That is lower than the actual. If it had been higher than the actual, it'd be positive.
Okay.
Okay.
So you said we have to divide by the 5814?
Yeah, you have to subtract this minus this and then divide it by this.
Oh,
Again.
okay, okay,
That's why I gave you the formula.
okay.
It's the experimental, which is this one, right? This is the experimental.
Mhm.
Minus the actual. The actual, see the molar mass is, so that's telling you that's the actual. Divided, once you subtract that, hit equal, then divide it by the actual again, times 100. And you should get negative 23.976609, you know, a bunch of numbers. So
Mhm.
you gotta cut it at 3 sig figs. We would cut it at 23.9, but that 7 is large enough to make that 9 go to 0, which
Mhm.
means that that 4 goes to, that 3 goes to 4 also. So that makes it
Oh.
24.0,
Mm.
right?
Okay, okay.
Okay. All right, so let's keep going. I'm gonna erase these because they're very annoying in my face. And I'm just gonna put the answers on here. So it'll be negative 21%, right? And negative 24.0. Oops, 0%. There we go. All right, so how many sig figs do we have on this number right here? Remember, we have sig figs, significant figures. Remember how to count them? If it doesn't have a decimal, you go from right to left. And you start at the first non-zero digit, and then all the other ones are significant. So the answer is 2, right? Remember that? What about number 4? It has a decimal, so we're going the opposite direction. The first non-zero digit is the 4, and then all the other ones after that are significant. So it has 3, right? Okay, here, number 5, how many do you see?
Okay, 4,
Nope.
3,
Yeah, decimal.
1.
That's right, correct. All right, what about number 6? How many sig figs? Oops, sorry. How many sig figs? Oh, darn it, this thing I hate.
5,
Does it have a decimal?
no.
Then you need to start with the 5, not the 0.
Oh,
Okay. 1.
See, remember, we're going from right to left, right? Remember Atlantic, because it's absent, Atlantic to United States, the Atlantic Ocean. So we are going to only use that one on that one. And these, that last 0 is just a placement 0. So we do not count it. Only those. And that makes it 4.
4.
Yeah, 4. Sorry, I have to put it there because otherwise it makes an extra line. I don't know why. Okay, now we need to change this into scientific notation or out of scientific notation, depending on which one it is, right? This one is not in scientific notation. Remember how we do that? We count the number of spaces to the place where we need to be, and the place we need to be is the first digit has to be between 1 and 9. So 1, 2, 3, 4.
5.
4,
Oh,
right?
4. Okay.
Right.
1, 2,
Okay.
3, 4.
So we need to
1, 2,
do 5.06 times 10 to the negative 4. Why negative 4? Because this number is less than 1. The whole number, I mean, is less than 1. So since the number is less than 1, it's negative. And you have to keep the number of sig figs, which is 3. All right, what about number 8? Okay, in this case is larger than 1, right? So we know it's going to be a positive, and the understood decimal point would be there. So we need to count how many times we
1,
need to
2,
back it up.
3,
So 1, 2, 3, 4,
4,
5, 6, 7, 8, 9, and 10, right? You see, I moved it 10 spaces.
10.
So, and the only 2 sig figs that count are those,
4.2.
right? Yes, times 10 to the 10th. Oops, not insert, sorry. There. Okay, now this one, we're gonna change it out of scientific notation. All right, since it's -3, we know this number has to be a small number, right? And remember I told you that -3 tells you how many zeros to place. You're putting 2 zeros less than what it says. And there's your answer. And yes, you do need to keep those zeros because they're there. That means they're significant. All right, for this one, we want to change it to 10 to the 2nd. So we move it in a positive direction, right? Because it is in a positive direction. Oops. Okay, I have to put it right there. I don't know why this thing is like that. 8,
0.
which one are you on?
The 10.
10,
10.
8, 2. So we moved it 1, right? Just now. This would be 2. So we only needed to move it 2. Then there is your answer. Right?
Yeah.
So when you have a negative, it's very easy. You're looking at the negative, right? To convert it, you just add 1 less 0 than what the number says. See how this only has 3 zeros? That's because the 5 is also one of them. So it needs to be 1, 2, 3, 4. But the zeros that you put in front of it is 3. Same here, look. You have -3. You only have 2 zeros in front of the 5. You see that? So always, it's easy to remember that if you can recall that it's the number of zeros minus 1. I mean, the number of decimals minus 1. So the exponent minus 1 is how many zeros you put.
Okay.
Yeah, it makes it much easier to just do it with the negatives. The positives is not the same. It just depends. And yes, I'm bringing these numbers. Oops. You know what? I'm going to go ahead and clear those numbers. And I'm just going to write them down instead because it'd be easier to remember that. And it's negative. And then this one was negative 24.0%. Okay, there we go. Normally, I like to put these in red so that you know which ones are the answers. So let's do that. There. Why didn't you go there? Oh, I know why. It's because I'm using the wrong one. There, this is the one I need. Okay. And I'm like I said, I'm just putting them in red so that you know that these are the answers, rather than, because this one has to be right there. And
So
these
we
rows.
have to turn this sheet in to you?
No, you don't. This is just a review, and I'm doing it with you. And
Okay,
and it's just for to get this one more, to get a look at this one more time before we proceed to matter.
okay,
So because we will not be seeing it again until we actually
Mhm.
have other problems. So
okay.
all right. So here we need to calculate and express answers in the correct units and number of sigfigs. Okay. So in order to do that, we need to divide. You notice that's a division. 0.00600 into 0.030. Okay. So we have to remember our rules. That's the main thing. The rule for division states that you cannot have more significant figures in your answer than the lowest amount that is present in the problem, right? All right. And the answer I get with the calculator 0.2. That's only one significant figure. This one has 3, right? Remember, we're going from left to right in the first non-zero digit that you encounter, and all the others after that are significant. And this one only has 2. So the answer needs another 0, right? Because we need to have 2 sigfigs. All right, so that's what we got. And then meters per second, right? And that's our answer. That's the correct units and number of sigfigs. Yeah, okay. Got that one? Okay, now here is a subtraction. When you subtract, the rule changes. The rule states that you cannot have more decimal places than the one that has the lowest amount. And in this case is 1, right? Because this one has 2 decimal places. Notice I'm only going to highlight the thing, and I'm going to make it a different color so that way you'll know it's a different rule. Let's make it green, okay? See, that's the rule in this one. Okay, so when you subtract 167.55 minus 87.3, my calculator says 80.25, and I'm going to write the whole thing down, even though we're not going to keep it all. And that would be grams, right? Because they're all grams. Okay, our rule says we cannot have more than one of these, right? So that means we have to cut it there. And that 2 is gonna go to 3 because that's a 5, correct? So then the answer is gonna be really 80.3. You see that? And that's the actual answer with sig figs and units. Okay, here we're adding 50.75 plus 155. Okay, my answer says 205.75. But what we know is that this has no decimals, right? So I can't underline the decimals, but we can see that there's nothing there. So since this one has no decimals, we have to cut it here. And that means our answer becomes 206, right? And that would be milliliters. Do you see why we're cutting it there?
Mhm.
Okay. All right, this is another multiplication. This time we're gonna switch the rule again. All right, this one only has 2 sig figs. Stop. I'm sorry. I'm trying to get this thing to highlight only the 2 sig figs, but it won't let me. Okay. And this one really only has 1, right? So that means our answer, whatever it may be, has to be cut down to 1 sig fig. So 5,200 times 0.07, right? That gives me 364. And that would be centimeters squared, because we're multiplying the centimeters. So let me get that. There we go. Square. Okay. So our rule is saying we can only keep 1 sig fig, and that would be there, correct?
Mhm.
And that 6 is large enough to make that 3 go to 4, right? So that means this number is 400 because we got to keep the hundreds place. Okay. And that's our answer right there. Here we have a division. Okay, when we divide, it's the same rule. So we're going to keep the yellow color. So 12.5 divided by 6.0. Oh, sorry. Okay. All right. When we're looking at these, we can see this one has 3 sig figs, right? Because this time, once again, it's the sig figs, and this one has 2. So the answer can have more than 2. The answer I get is 2.083333, right? That's what I got. And in this case, the grams would cancel, so that would be centimeter cube. Okay. Now, since we have to cut it down to 2, right? That would be here, correct?
Mhm.
Okay. Is that 8 gonna make that 0 go to 1? Yes,
Mhm.
it is. Yes, it is. So that the answer, oops, the answer is gonna be 2.1. And there's your answer for the whole thing. And this one, once again, is another addition. And in this one, it will be more helpful if I put them on top of each other. So I'm gonna do them with my first, and then I'll write it down for you. So we got 1,200 and 370. Okay, neither one of them have decimals, right? But we do have a placement. You notice that the zeros begin in the hundreds place for 1,200, right? And they begin in the tens place for 370. So when we add this, this is going to be 1,570, right? And you notice I have a line drawn through it. We can only keep decimals to the hundreds place. Since we can only keep decimals to the hundreds place, that means that is going to go to 1600, correct?
Mm-hmm.
Okay. So we are going to write that number down here, 1600. Oops, it does. I hate it when it does that, but I do have to do it. So if it might, and that would be milligrams, right? Okay. And now you know why, when you add these two. So in this case, we're going to switch cassettes and we're going to go to them. See, there are no real decimals, but there are places, decimal places, which is what this is about. And the one with the lowest amount of decimal places is this one. It only has to the hundreds. This one has to the tens. So it's the opposite when you got tenths and hundreds, right? So this one, we can say, no, see, that's not, yeah, no, it's still not gonna work. It's hard to do this one. Okay, so this one would only have it to there, right? And like I said, we gotta go with the lowest. So we need the green on this one, and this one only has it to there. So when you add them, you can see why that happened, right? Because we have to cut it down to the one with the least, and the least is 1200 because it's in the hundreds place. All right, that's that one. Let me clear that. All right, now we are going to do math, and notice this is a multiplication division. So remember, we always multiply first, carry out those rules, multiply first, carry out those rules, then divide and carry out that last final rule. Actually, the rule for SCHE doesn't matter right now, so don't worry about it. As far as that goes, what we're gonna do is we're just gonna do the top and the bottom numbers, and then we're gonna divide, and then we're gonna cut SCHE. Okay, so the top and the bottom numbers are 2.5 times 3.8. And that gives us 9.5. Okay. And like I said, we're not cutting SCHE yet. So let me go ahead and write that down here. So that's equal to oh man, sorry. I accidentally hit the delete button when I was looking at it and I lost it. Okay, so 9.5. Okay, so the top is going to be 9.5. But remember, when we multiply, we add exponents. So that's -5 plus 6 gives me times 10 to the 1, right? And that's going to be divided by. So let me get that 10 to the 1 up. So it doesn't look like 101. Okay, so now we need to do the bottom. We need to multiply 5.8 times 4.27, right? And that number I get is 24.766. And that would be times 10 to the what? Well, it's 3 minus 6, so -3, right? Let me not give so many spaces because then I run out of room. There we go. Okay, so it's 10 to the -3. Remember how we did that? We add the exponents, so -6 plus 3 is -3. All right, so now the next part is to divide. We're dividing 9.5. By 24.77, right? I get 0.388. No, 835, sorry, 8359. Let's just leave it there. Okay, so now here's the thing. We have to cut the sig figs. The sig figs based on the very first things. The lowest number that we have is 2, right? Right there. That's the sig figs right there. 2 sig figs. So that means this can only have 2 sig figs. The answer can. All right. We haven't yet finished some things, but we're just going to leave that there. Now, remember the multiplication says that you have to bring up the reciprocal, right? When you divide. Okay. So 1 is on the top and -3 is on the bottom. -3 comes up as +3. So this becomes 10 to the 4th. Excuse me. Okay, there. So that right there is the right answer, except for one thing. The significant figures aren't correct, right? And also the scientific notation isn't correct.
Sure.
So
Yeah.
since we can only keep 2, and that is the 0.38. All right, 0.38 is not a correct scientific notation, so we have to increase it by 1. So that means we need to decrease
Thank you.
the
You want
exponent by
some of
1.
this?
So it would be 3.8 times 10 to the 3rd.
Thank you.
And there's your answer. Okay, I'm gonna show you another way of doing this. Okay, if you have a calculator like the one I showed you, it works really well if you do this. What I usually do is I take all of the numbers, put them in parentheses. This way it's much faster than what I did, but I just wanted you to see the math. So you do 2.50 times 3.8 in one parentheses, then hit it, close the parentheses, then divide it by, open a new parentheses and put the bottom numbers, 5.8 times 4.27. And close that parenthesis, hit equal. That immediately gives me my answer, which is this. Now we don't have the exponents yet. So what you need to do is you need to do the exponents separately, like we did right here. 10 to the 1 for this one. We know that that would be 10 to the 1 because it's 6 minus 5 is 1, right? So the way that I usually do that, and I'm going to show you with my finger right here, is I will put this number 0.38, whatever it is,
Mhm.
times, and then this is 10 to the 1 on the top, right? And the bottom's going to be 10 to the -3. Okay. We know that we're dividing these two numbers. So 10 to the 1 plus the reciprocal of -3, which is 3, equals 10 to the 4th. See how much faster that went? Oh, did I? No, I increased, decrease. Sorry. No, that is 10 to the 4th. No, that is correct. So it's 0.3038, sorry, times 10 to the 4th. But we need to increase this one by 1. So we need to decrease this one by 1. And that's where I get the 10 to the 3rd. You see that? So basically I did the math part, all of this part already.
Mhm.
And I just do the exponents separately, and it works much faster when you do it that way. All right, let me clear all this gibberish here and go to the next one. Okay, so this one we're gonna do in the fast way, and then I'm gonna do the exponents differently. Okay, so we're going to do open parentheses, right? 15.7 times 12.3, close the parentheses. Then divide by, and open a new parenthesis, 2.20 times 5.80, close the parenthesis, hit equal. My number is already here. My number I've got, let's see here, I need my mouse back. Okay, the number I got is 15.134. And I'm just gonna leave it there because the rest is zero. It's okay. All right. And then what is my, you see, this is where it gets, we don't know yet. So we need to do the math for the exponents, like I showed you. So that's gonna be 7 and 3 is 10, right? We're adding, remember, when we multiply the exponents, which are right here, 7 and 3, right? I know it's kind of hard for me to make a circle like that, but yeah. So that gives me 7 plus 3 equals 10. And then -5 plus -3 gives me -8, right? See that? Okay, so when we are dividing, we need to use the reciprocal. So that means 10 to the 10th, right? And then this one goes up as a positive, plus 8. So the answer is 10 to the 18th. So now we can add that to this and say 10 to the 18th. Let me put that up. Now, the last thing we need to do is cut the sig figs. And according to our numbers here, our sig figs, the lowest number that we have here is 3, right? So we can keep up to 3 sig figs. You know, each one of these all have 3,
Okay.
including the one that you might have the most doubt about probably would be this guy or this guy. Either one, they both have 3. So 3 is the maximum sig figs. That means we have to cut it to this, right? Oops, come on, you stop. No, to that, right? So that means we need to erase these because 3 was not large enough to make that one go to 4. And there's your answer. This is your complete answer right here. See how much easier it became to do it a little bit faster that way? If you use them, if you use, like I showed you, the calculator with the parentheses. Basically what you did is you did this math first. You did parentheses here, times right here, without using these. These you do not use yet, right? Okay, so you just multiplying 15.7 times 12.3. And then divided by, you hit your divided by sign, and then you put another parenthesis, and you're just using the number. So forget about the exponents for right now. And then you did 2.20 times 5.80. And that gave you 15.134, right? Right.
Mhm.
Now, the one thing with this is it's not really the final answer, right? I should not changed it yet because is this correct scientific notation? No, it's not. Why is it not correct scientific notation? Remember the rule that says that we need to have the decimal, the one before the decimal between 1 and 9 is 15 between 1 and 9?
No.
So that means we need to back it up 1, right? So we're decreasing by 1, yes?
Yes.
So if we decrease by 1, we increase by 1. So they would be 1.51 times 10 to the what? 19.
19. 19.
19, right. Because we decreased this one by 1, so we increased that one by 1. Oh, and that's equal to there. I thought I put the equal on there. I hate when that happens. Yes. So that's how you do that. You see? All right. We are now doing density. We've done density before, so let's do density. And let me change this back to not the right color because this color is the wrong color. It should be black because it's not the right answer yet. Okay. I always usually highlight the, the red. I put in red the right answer, the correct answer. All right. Let's look at our problems for density next. All right. Remember, density is equal to mass over volume.
Yes, ma'am.
Right? And here they are asking what is the mass? That's the question. Okay. So remember the triangle that I did. Density, mass over volume, right? Okay. So if we want to solve for mass, the answer is density times volume. You see that? Okay. So let's clear all of this and let's start new. Okay. So we need density is equal, oh, that's a D, not a P. Sorry. Sometimes my fingers get a little too long. Well, 2.72 grams per centimeter cube, right? That's your density. And then our volume is going to be 24.9 centimeter cube. So that means that our mass is equal to 2.72. And that grams per centimeter cube times 4.9 centimeter cube. Centimeter cube would cancel and we would get grams. So once we do the math, we get 2.72 times 24.9. And the answer is 67. And running out of space because I wrote so big. I'm just going to put it here, 67.728. Okay, that's what I got. 728, sorry. All right, but sig fig wise, we can only keep 3, right? Because both of those have only 3. So we need to cut it right there. So the answer is 67.7 because that 28 is not large enough to make that go to 7, I mean. So the answer here, we're going to write it down here. It's going to be 67.7, and that would be grams because we want mass, right? Okay. Good so far?
Yes.
Okay. Let's clear all of that and go to the next one. Okay. You notice this one is asking what is the volume? You see that? That's our question. What is the volume? So with that in mind, remember our little density triangle? Density, mass over volume. We're solving for volume. It is mass over density. You see that?
30 minutes.
So we've got the density of helium is equal to 0.017 grams per liter. And the volume, we do not know. And the mass is equal to 38 grams. Okay. So we have mass over volume, right? I mean, sorry, density, mass over density. So M is 38 divided by 0. And so 38, it doesn't have a period or anything. So that's 2 sig figs, 0.017. And so is that. So this is 2 sig figs and so is this one. So we're going to cancel the grams, right? So when we divide, we get 38 divided by 0.017. That gives me this number, 2235 point, that's a period, 129. That's good enough. We can only keep 2 sig figs, so that's up to there, right? And that 3 is not big enough to make that 2 go to 3. So the answer is 2200, right? Because we've got to keep those sig figs, but we also have to keep the placements. So we need to add those zeros. So that's our answer, 2200 liters. So we put that, remember the liters is what we had left, right? So that would be 2200 liters. So that's our answer to put here. So that's what I'm going to type in here. And we're going to erase, not erase, make it red. All right. All right, so now we erase the rest. And I'm gonna let you guys do 21 and see what you get. And make sure you got the sig figs right. And the units.
Is it 29?
Hold up. No, that is not what I got. Remember, you're
Okay.
supposed to multiply density times volume to get mass.
Oh, see, I divided. Okay. So you
No, that's why
multiply.
you have a formula. Remember, I gave you a triangle.
Yeah.
And you cover the
Okay.
one that you want to get to. So if you got the mass, you have density and volume on the same plane. So that means you multiply, not divide.
Okay.
Okay. Yeah. We'll see it.
So I multiply density and volume and get 16.05.
That is correct.
Okay.
Right. So since you got 16.05, we have to check our sig figs. We have 3 here, right? There's only 3 sig figs on this one.
Mm-hmm.
And there's only 3 sig figs on that one also. So that means we have to limit, and I should have done that with these two. But there's 3 sig figs on all of these, actually, except for the bottom one, who has 2 only. Okay, so the sig figs, remember, are what matters for your answer too. So you said you got 16.05, right?
Mm-hmm.
Which is correct. And that would be what is our unit. We need that. Remember, every measurement has to have a unit.
Mm.
Oh, look, centimeter cube,
Mhm.
cube, right? That would cancel. So what would be our units?
Grams.
That's right. Okay,
Okay.
now, next thing is we have 3 sig figs, so we have to cut them. Right?
Mm-hmm.
So what is this 5 gonna make that go to 1?
1.
Okay, so then the answer is
16.1.
16.1 grams. That's right. There you go. Perfect. All right. Okay, now we're going to do conversions again. All right. Remember, milliliters to liters. Okay, so you've got to have your sheet, which we don't have, but I have it right here. So I'm just going to switch back and forth from it. Okay, so milliliters to liters, right? Milli, right here.
Mm-hmm.
Milli to liters, which is the unit. Okay, so we're gonna go up, right?
Mm-hmm.
So that means negative. We're gonna go 1, 2, 3. So it's 10 to the negative 3, right? Okay, so remember that. Clear all of this. And let's go back to the one we were at. I know it's kind of interesting to go back and forth between two. You guys should have your own sheets. Okay. So milliliters to liters. So the answer is going to be 177 times 10 to the negative 3, right? Liters. But once again, we know that that is incorrect because scientific notation says that we need to go 1, 2. So it should be 1.77 times 10 to the what? Negative 1. Because what we decreased here, so we increased there, right? So then that's your answer right there. I'm just gonna put the answer next to it because it doesn't really fit in here. And I think this is a PDF now. So let me write it right here. Okay, so the answer is 1.77 times 10 to the negative 1 liters. That's your answer on that one. Okay. Or remember, another way you could have done it, and that's just so that you remember, because we did this yesterday. I mean, yeah, yesterday was yesterday. Yeah. Okay, so you're going from a 10 to the negative 3. Oops, let me get that. 10 to negative 3 to 10 to the 0, right? Which gives you negative 3. You see that? So it's the same thing. So you got
5,600.
right. So you are going negative 3 spaces. You see that? So that's one way of doing it also. You can say 177. If you don't want it in scientific notation, you move back 3 spaces. 1, 2, 3. So your answer could be 0.0177, like that, liters. That's another way, which is the same as this, by the way. So, you know, either one that you do, you can do. Okay. So the next one is meters to centimeters. Okay, let's
1,600.
okay. I'm just going to show you the thing, but apparently you don't need it. Meters to centimeters, right? So meters is the unit. So we're right here. Actually, I can highlight, that'd be better. Meters, which is our unit. And we're going to centi, right? And we're going in a downward direction. So just positive. And it's 2 spaces, so positive 2, right? All right, so we can go back to the other one now. Okay, so you got 56. And you can do it either way, times 10 to the second, right? Which in this case, it would be 5.6 times 10 to the,
Yes.
yeah, because we're decreasing, so we increase. So it could be 5.6 times 10 to the third,
So
or you can say 5,600. Either
Yep.
one, right? Either one of those works. I like to stick to one format, which I like the scientific notation because it's faster to me. You know, in my view, it's faster, but if you want to stick to the other one, that's your, you know, that's the way everybody has their own. But now, if the actual question says, give your answer in scientific notation, guess what? Now you know how to do it too, right? And that would be centimeters. I'm just going to change it to red because that's the actual answer. All right. So kilograms, milligrams. Let's go look. We're going from, let me undo. No, that's not what I wanted to undo. Redo. Sorry. I wanted to try to undo this, but it's not going to work. Okay, so it's just going to undo these highlights. I need to get them off. Because we said we're going from kilo to milli, right? Okay, so we're going from kilo to milli. Okay, and that means we're going down. And downward is a positive direction. And we're going to count. 1, 2, 3, 4, 5, 6, right? So plus 6. All right. So now we can clear. Now see, sometimes it's necessary to do scientific notation because this number would be huge, right? So let's go and remember that this is a +6 that we're moving.
Yeah.
Okay. Nope, wrong one. I meant to get that one. Okay. So once again, we've got 0.093 times 10 to the 6, right?
Equals 93,000. I don't know if I'm correct.
Right. Well, we need to move 1, 2, and
Two.
we're increasing, so we need to decrease by 2. So that would be 9.3, and that's a point. My periods are very hard to do with your fingertips, times 10 to the 4th. So that would be the answer for that one, milligrams, right? See that? 9.3 times 10 to the 4th,
Yeah, 93,000.
which is 93 with 4 3 zeros. So 93,000. Yes, correct.
Ah, okay. Let's
See, so you did it right. Like I said, but it's a big number. So, you know, you can choose to put it in scientific notation, which is the same, right? In this case. But sometimes you're gonna get a huge number. Wait till you go to the last one. Oh, no, I don't want a home yet. I just want this one. Yeah, because I'm picky with that. I like it to look like it's supposed to. All right, and that is our answer. So we're gonna go red. All right, clear all of that. All right. Now look at this one. We're going from micrometers to decimeters. Micrometers to decimeters. Right?
decimeter.
So let's go back and look at this one. Let me get rid of these. Oh,
I know that.
no, yeah, there we go. Okay. All right. So micro to deci, right? Micro here and deci here. Okay, if we're going up, that means negative, right?
Yeah.
Negative what? Let's see.
4,
Remember, we count all the spots. So 1, 2, 3, 4, 5.
Negative 1.
Negative
Oh,
5.
5. Yeah.
Negative 5.
5,
Because 6 minus 1.
Yes, correct. But
Okay.
it's minus 6. See, it's negative 6 plus negative 1. I'm going to show you how that works if you want to do it that way too. That's another way to do it, which I haven't mentioned again, but yes, that is correct. That is another way of doing it. There's 3 ways of doing this thing, or several ways of doing this thing. Okay, so let me clear that because that's in the way. Okay, so it's negative 5. So we know that the answer is going to be 54,400 times 10 to the negative 5. And like you were doing, okay, so micro
400.
is 10 to the negative 6. But then we
Negative
add
6.
plus, right? And then deci is negative 1.
Okay.
Oh, sorry, not plus. We're subtracting. Wrong one. I meant to say minus. Okay, so when you add those two, see, because this is negative times negative becomes positive, right? So it becomes minus 6 plus 1 is negative 5, which is what we got. You see that?
544.
Mhm.
I don't know.
So, yeah.
0.544. I don't
Yeah,
know.
yeah, I know, right? So it's a small number. And see, in this case, that was much easier to do this. Just go 1, 2, 3, 4, 5. And it's 0.544, right?
Ah, okay.
Yeah. Or you can always do it the other way. Okay, let me erase this area because this is too much stuff and I can't get there. Okay, so in this case, remember we need the number to be between 1 and 5, right? So we have all this. Let me undo some stuff. Undo. No, redo. No, it's not letting me do it that way. So I'm just going to erase it. Okay. No, I need eraser. Come on. There. I need to erase that. All right. So now the way we could also do it is move the decimal as many spots, right, as it takes for it to be in the right spot. So 1, 2, 3, 4. And we're decreasing it by 4.
54400 or
So we need to increase this one, right? Decrease. So we increase this one by 4. So it becomes 5.44 times 10 to the negative 1, which is what we had. You see that? So either way, I mean, they're all good. It just depends on what they ask you to do. And that's why I want you to be prepared, whether it's significant big.
0.544.
So it'd be 5.44, right? And I just like I said, I like the scientific notation. And it's okay. If you do it differently, it's fine. As long as whenever they give you the answer, you can actually figure out the right answer. You know what I'm saying? Like if they give it to you in scientific notation, you can figure that out. If they give it to you in numbers, then you can figure that out too, because it's the same number, see?
Okay.
Okay, yeah, let's clear all of that. And then this one is terameters to hectometers. Okay, this is a new one. All right, let's do tera to hecta. All right, let me get these things out of here. Come on.
Yeah.
Tera to hecta, right? So tera's here. And hecta's here. And you can do it by the math way. So it's 10 to the 12 minus 2. So that's 8. I mean, 8. Boy, I can really do math. That's 10, sorry. 10 to the 12 minus 10 to the 2 is 10, right? That's one way. Or you can count the spots. You can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, it's 10. So this is in a downward direction, right? So it's positive, positive 10.
10
Yes.
minus
Huh?
2. Plus 2 or minus?
Minus, it's always minus.
Okay.
We're doing the difference between the two.
I know that.
All right, so minus 10. All right, so if we were to write this one down the way that I like to write it down, it'd be, oh, let me go up a little bit. Okay, it would be 1,500, right? Times 10 to 10, right? So we decrease this one by 1, 2, 3. So we increase this one by 3. So it'd be 1.5 times 10 to the 13. And that is a better way of writing it than putting all those zeros. Don't you agree? So let's do that instead.
You may not want to get it.
I forgot to put hectometers, so I gotta go back up here. Yeah.
I had so much trouble when I was kid.
Oh, come on, Em. Didn't want to come with me. Okay. So that is your answer. Remember, decrease something, you increase in the other one. So this is your M, right? So if you increase your M by 3, right? Sorry, not you increased it, you decreased it, sorry. Decreased it by 3. So that means you got to increase this one by 3. You see?
Mhm.
Oh, this is when you first went
Okay, so let's do the next one. Okay, 0.04 seconds to nanoseconds. All right, seconds to nanoseconds. So that's the unit, right? Okay, so in this case, I'm gonna do it again and just get rid of these. Okay, seconds to nanoseconds. So that's the unit. Because anything with nothing, you know, with no unit, no prefix has to be the unit. To nano, see, we don't even see nano. Nanoseconds is down here, okay? And this time we're going in a downward direction again, right? So that means it's going to be positive, okay? And we can count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? Or we can do the math. And the math goes like this: 10 to the 0 minus 10 to the negative 9. And remember, 0 minus negative 9 becomes a positive 9, right? So see, that's exactly what we got. Right, so remember that's a positive 9. So let me go back to that one.
Yeah.
And it is 0.040. Okay, so let's do that math here. No, come on. 0.04 times 10 to the 9th, right? Okay, so we need to increase this one by 2, right? So that means we decrease that one by 2. There's going to be 4 because there's nothing after, times 2 to the 7.
They're the ones that
Nano
doing all the work.
seconds. Yeah,
They were helping run but
That's,
yeah.
it's gonna be lots of zero there.
Yes, and see, sometimes, like I said, sometimes it's best to do it in scientific notation, period, because there's a lot of zeros. So it's just easier, and you can always convert it if you need to. Okay, and there you go. One last one. And then after that, we'll stop here and we'll continue the review next time in person.
Yes, ma'am.
All right, so this is deciliters. Oh, this one's going to be huge. Deciliters to megaliters. Okay, so let's go look. Deci to mega. Okay, let me clear these things out. Deci to mega. So we're going deci here. M to mega, which is right here. It's not that big, but it is big. Okay. So we got 1, 2, 3, 4, 5, 6, 7, right? So it's a negative direction because we're going up. So if you want to do it mathematically speaking, you say deci is 10 to the negative 1, right? So negative 1 minus mega, which is 10 to the 6, right? Correct?
Yes, ma'am.
So C minus 1 minus 6 is minus 7, right? Negative 7. So there you go. So it does work every time if you start with the right number and remember that you're subtracting. All right, so it's a negative 7. Let's go back to the other sheet. All right, so here we have, I'm gonna do it in, okay, so 132.6 times 10 to the negative 7. That's a lot of zeros in this way too, but it's not as many. Okay, so that's the answer. Now, We decrease this one by 1, 2. So that means we need to increase this one by 2, right? So that would be 1.326 times 10 to the negative 5.
Because 13260 milliliters. I'm not sure, but that's my okay.
That would be mega liters.
Who is that?
Okay.
Right.
Does that make sense?
Yes, ma'am.
Okay. So either way you want to go, you know, I mean, if you wanted to write that in actual notation, that would have to have 4 zeros before it. So it'd be 0.0001326. That's a lot of zeros. And a lot of numbers. And when you're doing that something in a calculator, you cannot put that many numbers. You see that? So that's why scientific notation is important, because you can actually put 4 numbers in an exponent. That's not a big deal. Okay.
Okay.
All right. So you guys are not having any problems getting into Connect, are you? Everybody's good with that?
Yes, ma'am.
Mhm.
Okay, good, because that's the one thing I want to make sure that, you know, remember it is right here. Where are you? I don't want to pass it. That's why I go save. So you click there and I can check and see if everybody's got an account. It's going to take a little while because it takes a while to load. Come on. Okay. And by doing that, I can just look. See, I can see people. If I just put in, let's see, like Jacqueline. See, she's in. Jocelyn, you're not in yet. You see?
Yes, ma'am.
See, I can tell.
Is that the attendance?
No, you
Okay.
need to go to Connect, how I showed
Okay.
you, to make your account so you can start doing your assignments.
Oh, I see.
Alicia, you're here. So everybody's here. And yet I know I've seen you. See, there you are. So everybody's got an account except you, Jocelyn. So you need to.
Oh, I
go
don't
to-
have it yet.
Yeah, I know. That's what I'm saying. So you need to do that
Yeah.
as soon as you can so that you can start doing your assignments.
Oh,
And you always have a reading assignment, you know, like right here. This one says reading assignment. See, this is what that book is. That's a reading assignment. Chapter
Okay.
1 assignment, like I said, you can do all of the math problems right now, right?
Mhm.
Anything that has math in it, like I'm gonna show you a preview. We can go ahead and adjourn. I mean, you know, this is done. We can stop. But
What
I
I'm
was
gonna
just-
click,
Yeah,
excuse
hold
me,
on.
ma'am.
Yeah, hold on. Let me go ahead and
Okay.
stop recording so that we don't record all this extra stuff what we don't need.
And it come out.
Okay, so here we go. For some reason, this is not letting me.
Uh-huh.
Okay. I'm trying to find my. I don't know what it is. Or maybe it's because I'm sharing. That might be why I can't go to my recording. Let me see. Okay, here we go. Meeting controls. Here we go. I just gotta. I cannot stop recording. I'm trying to stop the record. So what I'm gonna have to do is I'm gonna have to stop sharing and then stop the recording and then go back, okay? So let me do that first. Oh, there we go. I got it. I can stop the recording now.